Check. All right, so we have a decent turnout, so I'm gonna begin my lecture for today. So, yep, we're live. Hello there, guys. My name is Satyanarayan, and I'm the instructor for the Matlab course. So, hope you're all staying home, staying safe. So, before we begin with the lecture, I'd like to say a few things about Code the Universe in general. So, our motive is that we aim to teach coding to anybody, no matter whatever their experience level is, or whatever they know. We just want to have them be able to apply coding to their everyday tasks and benefit from it. And we do this completely free of cost. We believe we can achieve this motive, and well, that's why we're here. So that being said, this MATLAB course is to get your feet wet in the language of MATLAB or Octave, which is the open source alternative of MATLAB. And we'll be focusing primarily on getting your feet wet. We won't be going very really advanced into the subject, particularly because a language like MATLAB involves a lot of mathematics, and well, we aim to cover whatever mathematics is needed in this course, in this series. So, we just want to make sure that, people of all age levels and, experience levels should be able to learn this language through this course. So, I hope that's clear. So, if you have any issues or in the middle of the lecture you have any questions, you can always let me know on the Discord. I'll be, I'm going to answer your questions there if you do have any. Um, that being said, let's get started with this. All right. So, what is MATLAB or Octave? So, well, Octave is, of course, the open source alternative of MATLAB, and both these softwares are used for numerical computations and graphics kinds of stuff. They are particularly designed for matrix computations, stuff like solving simultaneous equations or computing eigenvectors and eigenvalues and stuff like that. A lot of engineering problems, these contain data which can be expressed as matrices and vectors. And so that's why these languages hold much of importance in those fields. So to be precise, both MATLAB and Octave aren't just programming languages, they are the software come the programming language, which means that they are both the software as well as the programming language built within the software. So we can certainly think of MATLAB or Octave as a powerful graphing calculator, but it shouldn't be confused with, some graphing software which we already have, like Maple or Mathematica, which are used for mathematical purposes. Because, Octave in general is more of a programming language come a calculator kind of thing. So, well, it holds a unique purpose. So yeah, Octave, let's talk about Octave a bit since, it's what we're using in this course. It was quite interestingly initially developed for a course on a chemical reactor design, and then it's currently distributed under the GNU public license. Well, MATLAB is developed and maintained by MathWorks, which is a well-reputed company in this aspect. And well, MATLAB is paid. So, well, if you have a subscription, feel free to use MATLAB, or if you don't, you can always use Octave. I hope you've already downloaded either one. So, well, don't worry about the syntax differences a lot. I'll make sure that wherever we encounter any differences, I'll let you know. We'll just make sure that all that stuff goes smooth in this course. So, yep, I'll be checking the forums for just a minute at this juncture to see if there are any doubts or any kind of stuff like that. All right, doesn't seem to be any issues there. Um, yep, so let's continue. Um, yeah, so at this point of time, I also like to say what octave is not, okay? So, octave isn't just that precise, just a plain graphic calculator kind of software. Again, to be remembered that, while performing calculations, we are going to be performing them in the computer's memory, which is completely different from a pure mathematical software. That being said, let's go into who uses Octave. Well, they're used for cell engineering and computational purposes in industry, academia. Well, for instance, let me say that, someone like NASA will use it to develop spacecraft systems, while race cars and race car companies like, say, Jaguar will, use it to display and, analyze data from their F1 cars. Well, universities and academia might just use it for mathematical or even medical purposes. Astonishingly, MATLAB has been used in medical cases too, including cancer research and a lot of cool stuff like that. It's very easy to write these programs in MATLAB or Octave. So one important question to be addressed before we finally move on into the course is, why not some other language like C++ or Python or that kind of stuff? Why MATLAB? So the difference is that C++ or Python, these are general purpose languages. They're written, we can write general purpose software in these languages, which are used for a multitude of purposes, while MATLAB and Octave written software are more focused upon the math part of it. So one main reason that I personally use MATLAB or Octave is for machine learning. And what I particularly find easy is that you can prototype different codes in MATLAB or Octave very easily. Particularly, if you need to write the same algorithm in C++ or Python, you need some modules and you need to use something like, for instance, NumPy or Array, and then you need to just build it and, test it and all that stuff. Instead, you'll be able to just run quicker, smaller scale versions of those codes in Octave or MATLAB. And then deploy it on a larger scale using one of these general purpose languages. Of course, Octave and MATLAB both are interpreter based languages, which means that they are um, converted into machine language or assembly language line by line, which definitely does make it slow compared to a language like C++, but nevertheless, it usually, caters to the purpose adequately and is able to, by this aspect, give, um, you know, um, numerical values to a very great precision, definitely. Um, so yeah, that being said, let's move on. So I hope you're able to see my Octave window here on my screen. If you aren't able to, let me know on the Discord server. So, well then, it's very important to understand what are the different parts of our software here. So as you can see, this is a file browser. So the main thing that you're going to be using the file browser is that when you're going to be opening MATLAB or Octave files on the command or the editor or wherever, if you're going to have to run them, you're going to have to be present inside the file where your MATLAB folders are present. For instance, let me just go to something and show you. So let's say I have some MATLAB or Octave functions here. Let me just run one of them, x2, let's say. Um, yeah, and you'll be able to see that um, it runs some stuff. You need not understand whatever is running now, but just understand that it's, running stuff. So yep, let's say I get out of this directory, I go to just user, I'll just edit my path over here, and then I try to run the same document um, on my command. Well, that's gonna display an error. See? So you gotta be present inside the file that you're working in if you need to open those MATLAB or Octave scripts that you have stored. I hope that's clear. The second most important thing is the workspace, which you're able to see. The workspace particularly stores your variables. You'll be able to see which variables are in scope over there. Um, Important stuff is that you're also able to see that the type of the variable that it is and the dimension of it. Dimensions apply to matrices, which we'll be explaining later in the course. So let's say I just click on one of these variables. I have plenty of functions over here. So if I display x, I get the matrix printed over here. So if I'm gonna, click on something like plot x, it'll be plotting my values. It'll be plotting the values of the matrices here. So that's the thing. So one more thing is that you'll be able to open anything in the variable editor. Okay, so the variable editor is something like the third page that is present on your right. So what you can do is you can change the values. For example, you can just change these values and I mean, you already have ways to do that in your command, but this is more easy way, So in general, all this stuff isn't really needed. But the reason I'm teaching you all this stuff is because you need to be able to, navigate around quickly and be able to perform your things in the most efficient ways possible. So I believe that's very, very important when you're running big programs. So, I'm just wanting to get you into the practice of doing that from now. All right, so let me get back to the command window. Okay, so below here, you'll be able to see the command history where, you'll have different commands stacked up over here. So one thing you can do is if you, want to use any of these commands that you've used before, just click on the command and well, it gets executed. So there I had typed CLC. So CLC means clear command, which just clears up the command window for you, just makes it up fresh so that you can enter new values and stuff over there. So all right, coming to the right side of our application. So first and foremost, we have the command window. Well, you might have installed Octave on your system. You might be guessing why this guy is getting, a colored command window with a black background and a blue foreground. Well, if you need all that stuff, you always, have all, options here. You can just go to window and then, you can look at your command window. You can change all that stuff and, just figure all that stuff out on yourself, play around. It's just cool stuff. I just personally prefer these colors when working on command. It's just cool to use. So the command window will just for the sake of doing something, let me just enter a command. Let me say I want to see the matrix y over there, so just enter y, and well, here it appears. So you can use the command also to open folders, MATLAB files, as I showed you before. So well, hope that gives you a current intuition about how to use the command line. I'll definitely be detailing the use of it further in the course, but right now I think that should suffice. All right, so um, yep, moving on to the editor. So the editor is where you're gonna write Octave or MATLAB scripts. So what scripts are that, on the command line, you're going to execute your code line by line. You enter a line, it immediately executes that line, and so on. But a script is something like you just type in a chunk of code, and then you go forward to execute it just on your command window as I'd shown you before. And that just works out that it runs the whole file. It runs all the lines in the code at one go. So I hope you got an intuition about that too. So yep, I have detailed stuff about the variable editor too. So I guess we're good to go. At this juncture, I'll again be checking the forums. If you have any questions, do let me know. Okay. Um, so wait. Okay, so all right. Um, you aren't able to hear me, are you? Um, let's see. Um, yep. Okay, you're able to hear me. So, I guess it went from the point CLC. I didn't repeat much after that. Anyways, so do you have any questions until what I've taken? Do let me know if you have any questions. I'll be waiting here for few more minutes. All right, so they say it's good. Anyways, yep. So I'll pause after the next interval of taking class, and then maybe if you have anything else, you can ask me then. Anyways, continuing here. Let's move on. Okay, so here's how to use the command window. So this is your formal introduction to coding in the command window. So number one and the most important thing is that you can perform basic calculations. So let me just do something very simple here. Yeah, that's 2 plus 2. That's going to give you an answer is equal to 4. Well, of course you can keep doing a lot of stuff like this. You can even use decimals, and you can multiply your values and do division, all that kind of stuff usually works. And but one more thing you need to understand is that when you're doing mathematical stuff, you also have well, are you able to hear me now? If you aren't, please do let me know in the forums, please. Are you able to hear me? I see that there are certain issues. They say it's lagging, but anyways, yep. Just do let me know. I'll be waiting here if at all any issues are there. Yeah. So anyways, so I hope you're able to see the calculations performed here. Um, so, yep. Um, So what are okay, continuing. We have some pre-built functions in Octave and MATLAB that are used for mathematical purposes. These are stuff like trigonometric functions like sine, cosine, tan, cosecant, secant, all that stuff. And then there's exponential functions, logarithmic functions, and all that stuff. I've posted a whole table of them on your lecture notes for this week, which you'll be getting at the end of this lecture. So hopefully you can access those at that time. Um, well, so, yep. Anyways, let me just, give you a brief by just typing in a few of those here so that you get a brief idea. Exponential 1, it shows a value as 2.7183. Let's take the logarithm of some value, 1, 2, 3, 4. Yep, that works. Or sine of some value, um, and that also works. So hopefully that gives you an intuition about how these functions usually work. So yeah, in general, let's go with the terminology now. So the plus, um, minus, multiplication, um, division, all these are known as operators. To be even more precise, they're known as arithmetic operators. And well, there's one more symbol, the modulus, which when used in calculations um, leads to um, modulus. Well, how do I say this? Well, a remainder during division. Well, anyways, so yep, they're known as operators, and these exponent, log, sine are known as pre-built functions. um, all right, so uh, all right, so okay, there are some hearing issues, I see. So um, well, what seems to be the issue here? Well, okay. I hope you're able to see my screen now. Yes, I apologize. There's been a mistake somewhere. I'm really sorry for that. This is all just my first time. I don't know where that got disconnected. I hope you're able to see it now, however. Okay, so the audio, there seems to be an issue with the audio, I see. Well, okay, so I guess, I'm really sorry, guys. I mean, yep, I don't know. I seem to be having network issues or something, but um, I'll try my best to go ahead with class. If it becomes really, difficult to follow, please, just take a look at the YouTube video when it's uploaded. I'll try my best to, do whatever I can based on my network. It's just that, I'm present in a very remote location in a city. So, yes, I do have problems accessing network here in India. Well, I apologize for that. Well, anyways, let's continue. I hope that we'll be able to run these a bit smoother for now. Anyways, so yeah, here we have the functions. So, well, yep, there we go. We just saw the mathematical functions. So, now that we know that values are stored, let's go to the concept of variables. So, variables are some things like chunks of memory. When we perform calculations or whatever in the memory, those are addressed using computer terminology, but we need ways to, understand those when we are coding. And variables are some things that facilitate all that stuff. So I hope that gives you a brief intuition of just what variables are. Um, okay, so let's just, play around with some variables. Let's perform a few tasks and let's just understand how these work. I'll be checking the thing again. All right. All right. So, um, all right. So, anyways, just a minute here. Um, are you able to hear me now? All right. So, Anyways, I hope I'll just try continuing with a class for now. But if I seem to have severe issues with this recording, because yeah, I do agree my network is kind of slow. Well, I'm not able to help it at the moment. But if it gets severe, let me just, try to work on it, and I'll just try whatever is possible. So, anyways, um, yeah, do let me know if there are any issues here. So, anyways, thanks a lot for cooperating and understanding. So, yeah, let's just play around with some variables here and understand how that works. So, let's assign the value pi by 180 to the variable degree. Okay, so here you might be wondering how pi is a variable. So the thing is that in MATLAB or Octave, some variables are predefined. They already have a value stored in them, so unless you're going to change them, they'll be retaining their original value. One such example is pi, which holds the value 3.14, as most of you might know. Others include values like infinity and not a number, which is actually a variable, surprisingly, and I and j, which are used in complex number terminologies. Those also exist. So anyways, these variables hold default values, and the ones which we define here, like degree, are called as user-defined variables. Well, however, if you're gonna assign a value to one of these default variables, then they are no more predefined variables. They come under the term user-defined variables. Now, I'll give you an example for this. Let's say I type in I, okay? So it's gonna show me that I is a complex number. But however, if I'm gonna assign I is equal to 1, then I get I is equal to 1. And the next time I'm going to type I, it will be showing I is equal to 1. Okay, so it's no more a complex number. So, well, that's how that works. Anyways, so now that I've done this degree is equal to pi by 180, I think some of you might have got the intuition already. What I'm going to be doing is that I'm going to be writing trigonometric functions using degrees instead of radians. So as you know, for converting from degree to radian, you use the term, you multiply the term pi by 180. So that's precisely what we're doing here. So let's say you want to find out sine 40 degrees. What I'm going to do is I'm just going to type sine 40 into degrees. And, well, okay, so seems that sine 40 into degrees has a value of 0.64279. At this juncture, let's add that for a while you'd now be seeing that whenever I type stuff, you see this variable called answer popping up. See? So, what this answer is, yep, okay, so seems my connection is good right now. Anyways, yeah. So, answer is another default variable. So what happens is when you perform a calculation, but you do not give any variable name for that, Octave or MATLAB automatically assigns it to a variable named answer. So, but in general, it's not preferred to use and the answer default variable, leads to a lot of chaos. You see the value of answer is just swapping on continuously. It was first 4, then it went to 796.53. So I don't prefer that. Rather, just store it in a variable. Just create a new variable. Let's say something num is equal to sine 40 into degree. Yep. So you assign the value to num. At this juncture, you might also be wondering, well, now that we know how to assign values to variables, what exactly can we have as variable names? Well, in general, a variable can have letters, capital and small letters, and underscores and numbers, but it cannot begin with a number, so you need to note that. So some examples of good valid variables would be something like num1 is equal to 12.34, and um, underscore num1 is equal to 34 point, let's say something, some value. That also works. But if I'm gonna give one num is equal to 23.2, well, see, that's a syntax error, so you can't use a variable name that begins with a number. I hope that concept is clear for now. So, well, that's it with variables. Anyways, let me just type in a few more stuff so that we get a more clear intuition. Let's say, I want something like some tangent of 50 degrees. Well, I'm just going to type that and I get that. But then again, as I told you, answer. So, we assign it to a value. Let's say this time we, name our variable tan 50 is equal to tan 50 into degree. So, well, that works. So that's pretty much it with variables. I guess, I've covered everything in that aspect of variables. So at this juncture, I'm going to be stopping again, and I'm going to be asking if you have any questions related to this section. I'll be tuning into the questions page here on the Discord. So please let me know. And of course, do let me know if you had any audio related issues too. I'd be happy to address them too. So, yeah. All right. Well, then, okay, that looks smooth. Well, thanks a lot for the feedback. Um, okay, so let's continue. Um, all right, so what's our next section? I've covered variables, I've covered user defined default. Well, yep. One more thing I forgot about was comments. Comments are something like the intro basics of any language in general. They are used to enhance the readability of your code. Well, surprisingly, MATLAB and Octave use a different style of comments. They don't use the hash or the slashes like you use in C++ or Python. Here, it's a percentage. So percentage, this is a comment. Well, comments are just your personal wish, when you're going to more professional development, it's always good to add them when you're writing big programs. They always help you keep track. It's something you need to gain by practice. You just need to, whenever you write programs, just, try to add comments before sections, and those anyways are your personal wish. If you want to add them, you can. Otherwise, but in general, I'd advise for adding them. So yep. So next of all, I'm gonna go into something which is essential for general purposes in MATLAB and Octave. In fact, generally, I'm required for any basic language that you're gonna learn, which is input and output. So, well, one thing I like to say before moving into input and output in Octave is that number one, that's not the main purpose of MATLAB and Octave. Well, you just need basic functions to, just get some values and, of course, print some values. You just need something to, solve the purpose. You don't need some, really advanced stuff in that aspect. Well, anyways, so we can segregate the input and output functions into two varieties when you're dealing with MATLAB or Octave. So, number one is the functions which come inbuilt in MATLAB and Octave. Well, these include two main ones, disp and input. So disp is something like Octave's own version of print. So let's say disp hello world. That's something like hello world is, its own kind of a custom in the programming society. So, I just didn't want to, um, whatever. Yeah. Um, anyways, all right. So where were we? Display. Okay. So I hope display was clear. And of course we have input. So let's say n is equal to input, enter a number. So you might be wondering why I'm giving text inside input. So how this works is that inside the input function, you're gonna pass whatever the prompt is as an argument. So in this case, you're gonna ask the user to enter a number, and you're gonna get that number as input, and you're gonna store it in n. Okay, I hope that makes sense. Okay, it's gonna ask me for a number. Let me just enter something, 1298. Well, and you see the value gets assigned to n. So, well, we're also dealing with strings here. So let me, give you an example of how it's done for strings. So let me just, string underscore one is equal to input, um, enter a word, and then you're going to be giving an s. All right. So here s is something like the second argument for the function, and what it conveys is that the input type is string. Okay. So by default, as you know, MATLAB and Octave are numerical software. They just assume that you're going to enter a number. So if you want to change this assumption, you just give that s so that the system understands you're going to input a string. I hope you get an intuition of that. So well, it's going to ask me for a word. Let me just enter apple. Apple. Yep. Okay. So you see, string one gets assigned a value of apple. Okay. So let me just use the disp once more so you get an intuition of that too. String underscore one apple. Okay. So apple is working cool here. Okay. Now that we're done with the basic MATLAB and Octave built-in stuff. We also need to understand that MATLAB and Octave incorporate some of C style print functions and input functions as well. So, well, for input, I think the input function built in MATLAB is more than enough. It solves all your purposes. But for a bit more advanced output, disp usually doesn't work as smooth as as expected. So here's where I'm gonna introduce a new function to you called fprintf. Those of you who have done some C might understand that there we use printf and scanf. Well, here printf works as well, but one important thing to remember is that printf works in Octave, printf does not work in MATLAB, while fprintf works good in both. So that's why I'm going to tell you to go ahead and just use fprintf. It just works perfectly well for everything. And this is very simple. You actually, whatever you want to print, um, you're just going to give it in the middle of brackets. So let's say my name is Satya. I'll just type that, and let's see. All right. Okay, so one thing you might have noticed here is that my prompt has moved from the side to somewhere here. The reason is that though MATLAB functions are designed to go line by line, in C how printing is designed is that there's no new line feed. It just continues on the same line. So what you usually do is that you use what is known as an escape sequence here. So the escape sequence here we use is backslash n. So what this does is that it conveys to the program that we're going to be moving into a new line. Slash n stands for new line. And if I'm going to execute this, well, oh, I'm sorry, there's a small typo there. Okay, so yep, fprintf, yeah, it just moves to a new line. See, so some of the other um, good escape sequences are slash t. Well, slash n leaves a new line. Well, slash t leaves a tab space. If you need to print an apostrophe, well, to override the default usage of it and to just print it, you'll use backslash apostrophe. Or if you need to print a backslash itself, then you're gonna print a double backslash. These just work in text. You can try out all that stuff. So hope that gave you an intuition of brief input and output. Well, in the next section I'll be covering formatting of output, so that we can deal with how to display numbers and stuff using the fprintf function. But before that, I'd again like to run a check in the Discord. If you guys have any queries, please do let me know. Now, is everything going smooth? All right. So I guess, well, that's working. Cool. Yeah. Okay. Anyways, just let me know if there are any issues. Anyways, thanks a lot for the cooperation. All right. So, um, formatting. So what is formatting? So formatting is something like you're entering a string, but you want to print a variable which is previously stored within the string. So instead of just printing the whole value manually, to print the variable, you just use what are known as formats. And the general syntax for formats is percentage %s. I think this is better accomplished by an example, so I'll just type in a piece of code here. Just look up the code and then we'll go on and I'll explain how this works. All right, so just let's take a look at this brief chunk of code which we've done here. So first, I think the first line should be obvious. I've taken a variable and I have assigned the value to it. And of course, in the second line, it's printing out the value just like that. Now inside the fprintf function, what I've done is instead of the place where I want to enter the variable, I've entered percentage %f. Okay, so you might be wondering what this percentage %f is. Well, percentage %f signifies to the program that in this place, a float is going to be displayed. So that being conveyed to the program, we then give a comma after the string and we give the variable which is going to be displayed over there. So what the program does while running is that it sees the percentage %f, it replaces the percentage %f with the value of num1 and it prints it out as is evident from this statement. All right, I hope that gave you an intuition. So let's say we want to do this with a string. So let me just enter another chunk of code which will show you how this same thing will work with strings. Let's say str_1 is equal to input enter a string. All right. Yep. So let me just enter something. My Alibaba. Okay, so I've entered a string. So now I'm going to be doing fprintf the string I entered. Oh, got a typo. Is percentage s, and well, of course, escape sequence, otherwise it won't move to the next line. So well, then we need to convey which variable is going to be replaced over there, which is str1, which I've done, and let's see what it's going to print. The string I entered is Alibaba. So well, I think that should give you an intuition of how to use the fprintf function. So let's just run through whatever we learned now. We learned about disp, input, and fprintf. These three are usually more than enough for running any command functions, even in major programs, because of course, they allow you to, just, simplify the purpose of input and output and focus more on the tasks like doing the math on the things. So anyways, one of the most important things is that, well, I feel this comes under input and output, but it's more of a general thing as well. So what happens is that when you enter any value, it's getting printed again. I think you would have noticed this by now, but if you haven't, look. If I am giving the value of a3 to the variable a, then it's just printing it out in the next line, which can be sort of irritating, especially when you're dealing with large matrices and stuff. It's going to be printing all the stuff you write, just for assigning it. Well, that might be um you know um, irritating at times. So what you're going to do is that you're going to end the line with a semicolon. This doesn't happen, see? So if you want the value printed when you assign something, just leave the line without a semicolon. Well, but if you do I mean, if you don't want the output happening, just enter a semicolon. That should just stop the system from um, giving those prints by itself. So, well, that should effectively conclude our study of input and output. Just, keep these three functions and the semicolon in mind. Nothing great, you should be good with these. Anyways, actually, just remember, let's actually run through one more thing, which, you might be confused with. Well, this is just something some of you might have already got this intuition, but in case you haven't, I just wanted to, clear the air here. So let me just assign one more number. Let's say num2 is equal to 34.32. All right. So I'm assigning num2 is equal to 34.32. Okay. So let's say I want to print um, both num1 and num2 in a string using the fprintf function. So as you see, for one variable, you just give a comma and you give the variable. Well, if you want to give two formats, here's how you do it. Let me just get that function. I mean the command from there. Yep. So what I'm gonna do is I'm gonna enter num2 here, and I'm gonna add one more here, and the second number is percentage f. All right. So well, the percentage f usually never gets confused, so remember that the variables here should be given in the order of printing. So let's say I want to print num1 here, I give num1 first here, and if I want to print num2 second, I give num2 second here. All right, so let me just check the syntax here and run this. Just a second. All right. I think if you had any doubts regarding that, that should have been clear. Anyway, that was just, an interjection to show you just, a different kind of thing which, you might as well use. So, anyways, moving on to the next section. Now we have done some brief work about variables and of course printing and all these stuff. What is basic to all this is that any value that is stored has certain types. Well, I've already used all these types, so let me just let you know about these types. So well, most of these stuff, all numbers are in general floats. You might be wondering here why I'm not saying integers and stuff, because Octave and Matlab do not use integers in general. They, moreover, they just work with floats. All values are stored with floats. But in general, they are stored to a very high precision. And so, you go to the workspace, you'll be able to see that they're stored as doubles. A double is nothing but, a floating point number with, more precision, or more numbers after the decimal point, to put it in a more simpler way. Then of course you have strings. Strings, of course, as I said, are arrays of characters, and while you might not be using them a lot for processing, you'll certainly be using them for input output and stuff in MATLAB. And I hope whatever I've typed in with regards to strings and the input methods for strings, everything is clear to you now. If not, you can always let me know in the forums. Yeah, and the other type is, of course, complex numbers. So let me just type in a complex number to clear the air if you didn't get that. So the variable I stands for root over -1, which is known as a complex number term. So these numbers are not real numbers. They are beyond. There are some things, they're just known as complex numbers in general. So if you know the math behind complex numbers and stuff, feel free to play around with these. If you don't worry. They won't be of much use unless you're into deep scientific computing, of course. And then, of course, then you have booleans. Booleans are key to logic. And let me just, give you an intuition of what booleans are. So let's say 2 equal to 3, answer equal to 0. Okay, so booleans are in general something like true or false. They can either take up the values true or false, but since MATLAB and Octave are numerical software, these prefer to use 0 and 1 instead of true or false. And as obvious, 2 is not equal to 3. So when I'm trying to say to the program that 2 is equal to 3, or you might be wondering why I put the double equal to here. Double equal to stands for checking for equality. For a single equal to just stands for assigning the value. So let's say I type a is equal to 3 as in this line. It means that I'm assigning the value of a to 3. While if I'm saying 2 is equal to 3, I'm meaning that I'm trying to compare both of these values for equality. Let's say I enter 2 equal to 2. Well, my answer is 1. See? So, Booleans again are just, one more data type. If at all we are going to deal with Booleans, I will certainly, let you know over there. But currently, I not feel that, over the scope of this course, in this particular session, we're not going to be using them any further. So, yep. To be we have one final section to complete today, which is utility commands. So, before that, I'd just like to, make a check over how things are going down in the forums. So, yep, just let me know if things are going good. If you have any doubts, please do let me know right now, and then we'll go into the final session. Um, yep, user Zanan TNT. Yes, I am talking about this forum. I'm sorry if you didn't get that. Actually, Discord is our forum. So, yep, I hope that answers your question. And yes, Navy Admiral, definitely you can assign booleans into variables as well. If you do look into this program, you'll see that when I enter 2 equal to 3, it assigned the value to the default variable, right? So just you can definitely play around. So yep, yeah, the answer to your question is a yes. Anything else? All right, so the forums are clear. So anyway, let's move on to the final session of our lecture today, which is the utility command section. So what are utility commands? Well, how I define these are these are just handy commands which you can use then and there while writing programs or working through the command, which just make life easier for you on MATLAB or Octave. To be honest, that's just the purpose of it. Okay. So the first utility command I'm going to be using is format. Okay. So as I told you before, numbers are stored to very high precisions in both MATLAB and Octave, okay? So what this means is that while displaying, you'll be able to either display the long form or the short form of any variable. So that's why these commands are used. So let me just check for give you an example using the value of pi. Let me just enter the value. Enter pi here. It's gonna give me 3.1416. Okay, so if I'm gonna enter format long and then I give pi, you see that it's displaying the number to a greater precision, as you can see. But now let me just change the format back to short, and then let me type pi. Well, again, it goes back to 3.1416. So if you want to see a number to a greater precision, well, that's when you should be using format. All right. So the second command I'll be dealing with is Control C. So for this, I'll have to run an Octave file to give you a better intuition of what's going to be happening. Or let me just, create something like loop or something, so that I'll be able to show you how this works. The basic purpose is that when some program is running or you run into some infinite sequence, or you're not able to get back to the command once you ran something, you got an error, or situations like that, you usually do this. So let's say while true, um, let me just do something, let me just um, print okay, I'm sorry, f print f let's just give an asterisk for our purposes here. Slam. Yep. So and end. And look, okay, so this program is just going on and on and on, and oh my god, now okay, how am I gonna return back? Okay, what's gonna happen? Just press the keys Control and C, get back. I mean, it gets back to your command line, and then you'll be able to go on smoothly from there. Okay, so well, next, we have what is known as the clear command. Okay, so you store values in variables. What if you want to change the value, or you don't want that variable existing? Okay, let's say I have the value a. Okay, and we see that a is equal to 3 as I have stored it here. You can also see that in my workspace here. So let's say I don't want the variable a anymore. It's just taking up my memory. I don't want it. I'll just say clear a. And now if I'm going to type a undefined, so it's basically cleared the variable a. Next is closing a file. So this works in general when you're working with scripts. Currently, I'm not dealing you with any scripts at the moment, but when I'm going to teach you scripting, I'll just, teach you how to script. But in general, whenever you're going to work on the command, you just, type close all. This means that it just, indicates you to, it indicates the program to just close all open files and start afresh. So it just, closes whatever files are existing. And of course, our trusty CLC command, clear command, you know, um, just clears it off, makes the scheme clear for you, just takes off the clutter. Yep, so the next two functions, the next two commands which we'll be dealing with are who and what. Okay, so who is a command which is gonna show you the current variables which are in scope. So let's say I just type who. Okay, it's gonna show me all the variables that are there. Of course, you can see the stuff already in your workspace. You might ask me why. It was just, just if you ever want to use a command to view it, instead of the workspace, these kinds of commands just come in handy. So just, it's good to know that stuff, but if you don't, also it's okay. Yeah, so for going to what, I don't have any current files in my document, so I'll open a file which has some MATLAB files, and then we'll go from there, I guess. Yep. All right. So yeah, so here I have quite a lot of number of MATLAB and Octave functions. So let me just go what. So you see, you'll be able to see a list of all my M files. You might be wondering an M file is. An M file is just a MATLAB or an Octave file. Well, you'll also be able to see .mat files. MAT files are Microsoft Access files, but those are the de facto ways of how you'll be storing your variables and a lot of other stuff in MATLAB and Octave. Well, don't worry about it. I'll certainly teach you how to do all that stuff. So I hope that gives you an intuition of what command. And then of course you have save as a function. So let me give you an example of this. Okay, so let's say I want to save a file. Well, here I don't have a file, so when I'm doing scripting, I'll teach you about that. But then I can teach you how to save a variable. So let's say I just save. Okay, deg conv deg. It's gonna save. If you didn't understand this previous command, let me just explain what it's doing to you. Okay, degree is a variable. I think you can see that over here. It holds a value pi by 180. Okay, so I want this degree value to be there. Okay, so what I can is that I can't just store it like that. I need to give it to a .dat or a .mat file. So what I'm going to do is I'm just going to name a data file named dgcon, which of course stands for degree conversion. Since I used it for degree conversion, just I just gave the purpose as the name. So you see that in my file browser I got the dgconv file. So whenever I just want it, I can just load dgconv, and it just gets loaded into my system, and then I can use degree from that file whenever I want to. Yep, I hope you got an intuition about how that works. Okay, so two final commands to go. The help function, the help command, which is the most important thing in my opinion. I use this a lot. So the thing is, you don't necessarily need to remember everything you learn from your mind. That I'd say on any day to any programmer, you need to know to work around with the documentation. It will help you, learn new languages at any point of time. So, and I also encourage you to do this a lot with MATLAB. So just type help and whatever you want. Okay, so let's say I want to know what the sine function does. I just type help sine. What it does is that it's gonna give me a whole column of what exactly is happening, and all the information I can get about that. So help is just you can use it for anything, you can even use it for print commands. If, let's say, fprintf, I don't know what fprintf does, I want to know what it does. It gives me some info about what fprintf does, and all that stuff. Just when you're free, play around with the documentation, learn to do it. Well, you need not necessarily access it from the command. What you can do is you can go to window, show documentation. Wait, where is that? All right, so yep, you usually get it down there. I haven't. Well, okay. I mean, yeah, if you want to do it, just use the help command, or you can even go to the window and you can get the documentation, or click Control Phi and you get the documentation opened. So there are plenty of ways to do this. So just play around with the documentation. Look up new functions. If you're raring and you're really interested in this language, it's always a good thing to do that. So yep, I think that's it for today. One final thing, of course, nothing gets over without this: the exit function, which helps us close our command and get back to whatever damn fun we were doing. Yep, it's gonna close everything. And well, okay. Well, that's it for today's lecture. Well, I'd just like to ask if you have any questions before I close. Just let me know here. Yep. So before I close, anything else, guys? Of course, I've designed your homework too, and well, all I can say that it's interesting. So, yep, have fun. Yep. Let me actually give you a clue before you go to homework. I just, wanted to do this for fun. Okay. So, one thing I'm going to be telling you about, oh, okay. Yeah, the exit function. Well, that's a very basic thing, of course, I agree. But then, sometimes the basics are the building blocks for anything, I've always found out that, having a good knowledge of the basics, when you're doing bigger programs, helps you just navigate around. Anyways, coming back for the homework thing. So understand that calculations in MATLAB and Octave are done in the computer's memory. Okay, so keep this in mind while you do the homework. I hope it will help you. Okay, so anyways, thanks a lot for joining, guys. Means a lot. I know there were some network issues. I'll try to do my best from my side. Do let me know if there was any improvement or scope for improvement from my side. I'll try to do the best from my part. I hope you have a fun course. Well, thanks a lot. I'll be concluding my lecture here.